we just did normal distributions, and we had this nice bell curve with our mean in the middle. And then we memorized a couple of approximate percentages of like, say, within 1 standard deviation or 2 standard deviation. We found that if we were within 1 standard deviation, that ended up being 68% of our data, or 68% chance that some data piece falls between those two. But our data doesn't necessarily cooperate, so we might not be exactly 1 standard deviation. And that's what the whole z-score thing was doing, was finding out where in this distribution that we are. Now, luckily, our calculator can do a lot of this heavy lifting for us, and we're going to take a look at how to use the TI in order to answer some of these questions. So, Joey's average score in a game is normally distributed with a mean of 18 and a standard deviation of 3. So that means in the middle here is 18, and then 1 standard deviation is 21, and then 2 standard deviations is 24, and 3 standard deviations is 27. And then if we went to the left, we would have 15 and 12 over here. So we want to know, now we could do this one with the estimate from what we memorized already, but we're going to go ahead and use the calculator. So we have our calculator out, and when we did lists, we did the stat menu, but we're actually interested in distribution, which is under this vars button. So we're going to press second vars, or distribution. And it brings up a list, and there's a lot of things we can do here. And really, we're only going to be interested in normal, CDF, and inverse normal. So today, though, we're going to be doing normal CDF. So we're going to go into there. And our lower value, so this means the lower bound, and this means upper bound. I'll talk about that in a minute. Let's first fill in our mean. So our mean, it wants me to put some, I'm going to have to put something there. So I'm going to put in 10 to the 10th, and I'll describe why I did that in a second. Okay, so this is our mean. Our mean was 18 points. And our standard deviation was 3 points. So I got that straight from the problem. But up here, these mean the boundary. So in this case, I want the probability of more than 24. So 24, I could be over here, I could be here, I could be here. I want 24 or more. So the lower bound is 24. That's the least that we're going to want Joey to go ahead and score. So our lower bound is 24. So why did I put 10 to the 10th here? Well, technically, we're okay if he scores 1,000,000 points or, 1 billion points. It's not probable that he does that, but we would be happy with it because we're asking for more. So our upper bound, when we go to our calculator, is going to be 10 to the 10th, and that's a way to say basically infinity. And we're just going to press enter here. We filled in our mean, we filled in our standard deviation. We're going to press enter, paste that. It fills all of this stuff out for us. We don't need to worry about that. We're going to press enter, and we get 0.02275. So what's that? Well, if I move the decimal point over, that's 2.27% chance that Joey scores more than 24 points. Okay, probability that he scores less than 13 points. So I bring this back up, and I'm not going to need to type in my distribution all over again. So I press second, go over here to vars, distribution. Going to go to normal CDF. It's already mostly filled out for me. The mean and standard deviation haven't changed, but my bounds have changed. So I want the probability that he scores less than 13 points. So 13 is right here. See, this is a case where we aren't exactly within 1 or 2 standard deviations. We're in between 2 standard deviations. And this is all the probability we want. This goes on forever down here. Maybe he even scores negative points. I don't know. But so our lower bound this time is going to be negative 10 to the 10th. Press enter. And our upper bound, we don't want him to score more than 13 points. And we'll press enter. And we'll just press enter, pasted all that, and 0.04779. So So that's the non-percent version. The percent version would be 4.78% after we change the percent. The probability between 16 and 20 points. So that's easier to think about where our bounds are. We're going to score the lower bound 16. Now the lower bound actually has to be the smaller number. So between 16 and 20 points, what's the probability that he does that? Well, apparently 0.495 or 49.5% chance he scores between 16 and 20 points. Okay, a computer company found that on average it will sell 400 CPUs with a standard deviation of 15, and we're going to plug all this information in and answer the question. So we go to our distribution, and we are going to go to normal CDF, and we want between 390 and 420 sales. So first of all, this is our mean. On average, another way to say mean, and here's our standard deviation. But we want between 390 and 420. So 390 is our lower bound, 420 is our upper bound. Our mean is 400, and our standard deviation is 15. We'll go ahead and plug all that in, and we'll press enter, and we get 0.6563. So that's a 65.6% chance. How about the probability of no more than 350 sales? So if I go to my distribution, normal CDF, and my lower, well, no more than, so negative 10 to the 10th. My upper bound is 350. And we'll go ahead and paste that, and we'll press enter. And now we get this e to negative 4. So we have 4.29 e negative 4. And that means move this decimal point 4 places. So 0.000429. Now that's not a percent. That's our decimal. So it's 0.0429% chance after we get rid of the percent sign, or get the percent sign. Okay, probability no less than 440 sales. So thinking about this, you can draw a sketch if you want to. Our mean is 400, so 440 is somewhere over here, and we want no less than that. So all these sales over here. Okay, so 440 is our lower bound. So go to our distribution, normal CDF, and we're going to do our lower bound's 440, and our upper bound is infinity. We're okay if we sell infinity cars. That's all right with us. So 10 to the 10th is a good way to tell our calculator, keep going. Press enter. 0.0383. Your calculator might put 3.8 e negative 3. If so, you're going to move your decimal point, see 1, 2, 3 spots. So what is that? 0.383% chance we sell no less than 440. Okay, a couple more questions. The cost of gas is normally distributed with a mean of 350 and a standard deviation of 12 cents. Suppose there are 50 gas stations in the area. Now look at this question as how many gas stations price gas at over $3.60. So we aren't looking for the probability, though we need it. So we are going to first find the probability that we get a gas station over this amount. So we're going to take our 50 gas stations and multiply by the probability that we get. So let's go to our distribution, and we go to our normal CDF. Now, for some reason, we're interested in gas stations that are charging more than 360, right? So 360 is our lower bound. and our upper bound is 10 to the 10th because that's infinity. Our mean is 350, and our standard deviation was 12 cents. So I put that all in. I'll paste that, and I get 23. And there's no need to change that, but that is 20.23% chance. But I'm going to not change it to a percent. I'm just going to multiply by a decimal. So I'm going to take my answer here, and I'm just going to press times 50. All right, I get 10. So there are 10 gas stations that are charging over 360. But of course, we're interested in gas stations that don't charge more than $3.30. We want to save some money. So if we take a look at our distribution, what we're talking about here, here's our mean of 350, and here's our 330 or $3.30 about, and we're interested in these cheap gas stations down here. So we'll go to our distribution and go to normal CDF, and our lower bound is going to be negative 10 to the 10th. What does that mean? Well, they pay us. Not probable. But sure, we wouldn't argue with it. Our upper bound, we don't want to pay more than $3.30. Our mean is still 350. Our standard deviation is still 12 cents. Okay, we'll paste that all in, and 0.04779. And this should be $3.30. Now we're going to multiply that by our 50 to see how many gas stations we're actually talking about. So times 50, we get 2.3. So 2 gas stations fit that bill. All right, one more question. In Chemung County, the average ticket is $200 with a standard deviation of $25. The court is reviewing 30 tickets today. How many tickets are between $180 and $210? So again, we go second distribution, normal CDF. Our lower bound is going to be 180 because we want between 180 and what was it? 210. So 210's our upper. Our mean is $200, and our standard deviation was $25. Okay, 44, so 0.4435. So after we round 36, and now we're going to multiply that by 30 because we want to know how many tickets. So times 30, and we get 13. So 13 of these tickets the court reviews will be likely be between those two. How many tickets are less than $170? So again, thinking of our normal distribution, we're down here somewhere. So we go back to our distribution, and our lower bound's negative 10 to the 10th. The court pays you some money for getting a ticket. Not probable, but is technically part of this distribution because this distribution goes on forever. So our upper bound is going to be $170, and everything else stays the same. So I just keep pressing enter, and I'll press enter, and 11.5, so 0.11.5 times 30. And that gives us 3.5, so basically 3 tickets are less than $170.